Still dreaming your dream job? Join Gangboard now and make it real.
This conference will now be recorded.
Hello everyone, welcome to Introduction to Cloud Computing. So before cloud computing or before the cloud, what was there? So before cloud computing, if anybody wanted to have their own IT environment or they wanted to have their own website, they had to own something called data centers. A data center is basically infrastructure inside which your servers, your networking hardware, your cables and everything had to be placed. It had to be fully built, and it used to support the servers, and on top of the servers your applications get deployed and were made available to the users. So if I want to build my own data center, what do I need? The first thing is I would need acres of land. So I need to purchase the land or get it on lease. So I need a very huge amount of land. On top of this land, I can build my infrastructure. So basically a huge building inside which I need a proper networking, I need proper coolant, I need a proper power source, right? So that this can support the servers which are going to stand on these data centers. So similarly, I need to purchase all the hardware, I need to purchase all the software, I need to get or hire skilled manpower who can basically help me in maintaining my data center. So they need to do in and out everything from managing the data center to repair, and even the disposal of waste and everything has to be done from the data center. So waste is e-waste here, so you cannot just throw it away in the dustbin. It has to be properly disposed. So that also costed money. And to do all this, I just cannot go ahead and build a data center wherever I can purchase the land. No. So I need approval from the local government bodies to create my own data center. So building a data center takes huge amount of time. At least like 9 months to a 1 year of time is required to build and set up a data center. So if a new project is coming for me and I don't have space in my existing data center, definitely my project has to wait for at least a year till my new data center gets ready so that it can be hosted and can work on top of projects. So before, the big companies like IBM and all, they had the money or they had the capital to purchase and build data centers for their own. Others didn't had a capability, so they were not able to have the data center. So a data center is a capex model. It's a capacitive expenditure model. So basically, like first I need to invest and I need to build my data center. Then once my project starts running on it, I'll be making money out of it. Okay, it's a capex model. So that's number one. Second thing, if I'm building my data center in somewhere, say UK, then people or users who are there in US will be facing a little bit of latency when they try to access my services or my website, which is hosted in UK. So to avoid that, what I need is I need to build a copy of my data center somewhere in the US also, so that the population of US or the users in US will be able to access my data faster. So it's an infrastructure redundancy basically. Similarly, if my application needs to be available in Asia Pac region, I need to have a data center somewhere here also. So that is problem number one. Second problem, if something goes wrong with one of my data centers, say for example there was a natural calamity like a earthquake or a lightning strike, so if my data center goes down, the data is going away. So I need to maintain the data in, or I need to create a copy of the data and save it also. For that, again, I need a storage environment, right? So the redundancy of infrastructure plus again the cost to have a backup and backup of the data and redundant data needed to be maintained. If there was a patching activity, there was an upgrade of the environment, again my downtime of my application will be required, or my application will be going down, or my data center is under maintenance and repair, so my application will not be available, right? So slow service, whenever there is an issue, the service was always slow. It took a time for the support team to get into the data center and fix it, or if The fix was not available. It was very difficult to find someone who can fix it. And like I said, so people or users who are away from the data center had a little bit of latency over the internet to get access to the site. Whatever applications were being built at that time with private data centers were not available globally. It was available only in selected region or selected space, okay, where basically your application can be accessed. And applications were not available across all devices. You need to come to office to work on application. Okay, so you're only in your office, you'll be able to access the environment. So why there was a need for the cloud? Whatever we discussed till now was happening because the data center capability was restricted to specific companies. But the cloud providers, what they thought is, what if we take care of the data centers and we provide the data centers to users or clients as a service? So the first requirement for the cloud was the services which are going to be run should be always on. It should be 24/7 available. It should never go down. Okay. So if there was an increase in demand of the application, I should be able to add more infrastructure, or like when there is a demand. And if the demand is decreasing, I should be able to remove infrastructure also. All this provisioning of infrastructure or services should be super fast. I should not be waiting for like months and days or weeks also to get something provisioned. It should be super fast. If there was any issue like a earthquake or a terrorist strike or a natural disaster, the data center should be able to manage it, should be able to tolerate that fault, and my application should not go down. Okay, so that is basically your fault tolerance. Backup, my data center or whatever services was being provided or the applications, it should be automatically backed up and it should be prepared for disaster recovery. In case of a disaster, automatically the backup should override the existing issue, and the services should be able to continue in a business as usual process. Global reach, from anywhere in the world, across any devices, people should be able to access my service. That's the global reach, which was a requirement which brought in the cloud. It should be highly secure. The data, what I'm putting in, the services, what I'm using, my people, my customers, everyone's data should be highly secured. No one should be able to breach the data or get into the data center or get access to the data by hacking into the data center. So highly secured was a security was a big requirement. Finally, all these things needs to be available with the optimized cost. I should not be burning my pockets, or I should not be spending a lot to achieve this. If there was a way by which with a minimal cost all these things can be achieved, then I would be happy to deploy my application over there. So this was the need why which brought in something called the cloud. So what is this cloud? So cloud is basically an environment. It is like a data center provided to you as a service. What kind of services? You get the infrastructure as a service. If I need a virtual machine, if I need an environment, if I need a system, I'll get it. It's an infrastructure given to me as a service where the client manages only the top half, that is your operating system, middleware, runtime, whatever I want to install in my machine, I can install it. My virtual machine, I can install it. And the physical network, the physical storage, physical servers, everything is managed by the cloud vendor. Let it be Microsoft Azure, let it be AWS, let it be Google Cloud. So the physical network, the physical storage, the physical servers, the physical data center is being managed by the cloud provider. Similarly, they also provide something called platform as a service, where you will be responsible for only your application and your data. You don't have to worry about what OS is running in the background, what middleware is running, what's the runtime, what kind of servers are there in the background, nothing. All these things will be taken care by your cloud vendor. You only need to worry about your application. And the final one is the software as a service, where you're basically using the software and you're trying to consume it from a client. You don't have to install it. You can directly consume it from your client through a any kind of client, whatever you're installing. So let it be Facebook, let it be WhatsApp, Instagram, Google, whatever you see, all are basically softwares. You're using it as a service. You're not installing Google, you're directly using it, right? You're not installing Facebook, you're using it. Whatever you install, it's basically just a client. Because when I upload any photo into Instagram, it doesn't get stored in my local device. It gets uploaded to my cloud account, right? So that's basically the cloud. It's basically data centers which are provided to us as a service and managed by the cloud provider. What is cloud computing? So when it comes to computing, basically what they mean is you are going to work with the services, or you're going to build services in this cloud environment. So at the very basic, when we talked about infrastructure, you're going to build virtual machines, you're going to build containers, you're going to build storage accounts, going to build blob storage, queue storage, file storage, disk storage. When it comes to networking, you're going to build virtual networks, you're going to build load balancers, DNS, Express Route, Traffic Manager, VPN gateways, app gateways, right? Appliance gateways, all these things you're building as infrastructure. In case of platforms, you're building media services like your YouTube, you're building integrations like your Logic app or Power Automate, you're building compute services with like Kubernetes and Docker, you're building application services like mobile apps, web applications, service fabric, microservices, functions. You're building developer services with DevOps, data services with Azure SQL, where without having to manage a SQL server, you still have the access. Without having to manage a virtual machine, you still can manage the entire SQL server. So similarly, cognitive services or the chatbot framework, Cortana, analytics and IoT services, a hybrid cloud where authentication and everything is coming into picture. The security and management is taken care by multi-factor authentication, authorization is taking place, automation accounts are there, job schedulers are there, key vaults are there, right? So all these services basically comprises of your cloud computing. So when you are building an application in the cloud, you're using all these services or any of these services. That's basically how you're doing the cloud computing. So this is basically what is the cloud, and what all things you can do using cloud computing. So whenever you're building any application or service in the cloud, it is basically cloud and cloud computing in the background. Thank you.